Thank you very much for the welcome here at Area 41. It's a pleasure and an honor to open the Tech Talks on the main stage with my talk on the core rules Paranoia mode. In fact, I've been looking forward to this presentation all winter and spring when we were developing the core rules Paranoia mode. Have you guys read Jessica Barker's article on the imposter syndrome last week? Who has read that? You're not familiar with that. You have read it. Arno, hey. So Jessica Barker had this idea that in the IT security industry, a lot of people have this feeling that they're self-appointed experts without a formal education, that they're an imposter somehow. And when they're standing on a stage addressing the audience, a lot, if not most of IT security people feel like they're a fraud. They're an imposter. And anytime somebody could walk up to them and tell the world that they're naked. We're standing naked in front of the audience and we fear to be disposed. We fear we're imposters. Now, as Michel has told you, I have a PhD in medieval history, and what you're about to witness is a medieval historian pretending to know something about application security. And if there ever was an imposter in the IT security industry, it must be me. Take of this what you will, but I sure hope you enjoy the show. Mod security talks are usually in front of smaller audiences. And if I look around, some of you lack this crazy look in the eyes, which you get from writing regular expressions all day long. This tells me somehow that I should probably introduce web application firewalls, mod security, and the OWASP mod security core rules to begin with. That is a bit boring for the mod security people around, but I think it's really necessary for the rest of the audience to really understand and appreciate the rest of the talk. So mod security guys, this is the moment where you could take a nap or write a few regular expressions. We'll wake you when we need your expertise. Good. So mod security is a web application firewall, one which probably has the biggest user base in the internet, the highest number of installs. But web application firewalls, they have a very bad name. The bad name is probably due to the PCI standard, which made the use of a WAF mandatory. Now, PCI has been called idiotic so many times, I do not want to repeat it here on stage. But if there is one thing that PCI got right, it was to make a WAF mandatory. Now, of course, in an ideal world, we wouldn't need a web application firewall. In an ideal world, there wouldn't be any buffer overflows in applications, and applications would not expose SQL injection vulnerabilities to the internet. And developers would actually know what a secure flag on a cookie is. But the internet, being man-made, is as imperfect as anything else man ever built. So, as it turns out, buffer overflows are still very much alive, and applications are plagued by forever days. Do you guys know what a forever day is? Not really? A forever day is a zero-day exploit which is not fixed, ever. So it's a flaw which is persisting. Nobody's fixing it. So buffer overflows are still alive, applications are plagued by forever days, and the developers of the legacy applications left the house without leaving a number or any sort of usable documentation behind. And that's the situation. And now WAFs to the rescue. We have to patch a service without touching the source code of the application. We have to do layered defense now. We have to do defense in depth, as they call it. We impose access restrictions on the services, and we install mod security as a means of defense, where we hope to do virtual patching. That's a crazy term. So you provide a virtual patch to fix an application which you cannot really fix. And that's a very stupid idea. I agree with you. But then I did not write the goddamn code. And all I'm trying to do is helping fixing it when the developer is already gone or cannot be reached. So web application firewalls, that's how a web application firewall install looks very often. I see three different kinds of setups. There are the naive setups, the overwhelmed setups, and in rare cases, functional setups. What is a naive WAF setup? A naive one is where the administrator, or at least his manager, thinks that the WAF is functioning. The complete lack of false positives could point them in a direction that the WAF is actually not working properly. It's probably not enabled, it's probably deployed out of band, it doesn't see any traffic, or if it sees the traffic, it's sending the alerts to def null. And you would be surprised how many people invest precious money into licenses of commercial WAF products and then have them collect dust in a corner. Very often people are overwhelmed. So these are new projects, new sysadmins, they approach mod security or the sort of WAF, they deploy it, and they bury it immediately underneath a huge avalanche of logs, false alarms, rules, reports, and all sort of madness. Deploying a web application firewall is hard, and when you do it the first time, you're really overwhelmed. Without very good guidance and very good team, you will not pull this off, and people very often shy away when they first see it in action, when it has first trashed their setup, and they can no longer continue to be productive. And then in rare cases, people step out of this situation, and they actually manage to run a functional mod security setup. And what I mean with functional is a tight blocking mode, which is actually protecting the application. It is actively monitored, so the alerts are actually meeting somebody, and the configuration is continually adjusted to the dynamic and fast-moving application, which is continually developed. The core of all this problem is, of course, the rules, because the engine itself is innocent and nice, but it's the rules which act as the sensor. It's the rule that interact with the requests, with the internet traffic, and it's the rules which generate the few real alerts and the great many false positives. Now, mod security is no self-learning masterpiece as some commercial products. It is also no neural network, and it's no black magic. It's much more a mechanical piece of code with granular control, and I made a few rough edges around the corner. It's much like a mechanical watch where the mechanic would use his little screwdriver to interact with the setup and try to change the configuration within to make sure that the internet traffic passes the WAF without too many false alarms. This is the real image of a mod security installation. This can be understood, but if you look inside this watch, it's a bit complicated, isn't it? Web application firewalls can be defined by rules, and rule sets come in two forms. They come in a whitelisting and a blacklisting form. We also call this positive or negative security models. You all know the whitelisting. That's how a network firewall works. You close everything, and then you allow to select the few ports which you want to see, the ports where you have an application running. That's nice and everything on the network level, but when you move up to the application layer, it gets very complicated. SE Linux is an approach to run a Linux kernel in a whitelisting mode. That works, but it's hard to set up. Using a WAF in a whitelisting setup works, but it's hard to set up. It's a lot of work, and people are usually not willing to invest the resources it takes to set this up. My advice in these situations is Maybe you don't need a complete whitelisting setup. Maybe it is enough if you do selective whitelisting. That would mean to concentrate your whitelist on the weak spots of your application, like the login page. This is exposed to the internet. This is where you can deploy a whitelisting rule set without too much hassle. I mean, the login page is usually fairly simple. After the login comes the complicated website, the complicated functionality, where whitelisting would be very hard to do. This is probably over the edge. So do selective whitelisting for login pages, probably upload forms on other weak spots of your application. But with web application firewalls, people usually do a blacklisting approach. A blacklisting approach is much more what Snort is doing, or the antivirus companies. And of course, antivirus is broken. Why is it broken? Because it relies on a database of patterns. It relies on a database of known patterns. This means that everything which is new is unknown. So all the new attacks pass, and that's broken by design. This is not how it works. So mod security has a generic blacklisting rule set. And this is, in fact, the OWASP mod security core rule set. This is an idea which is about 10 years old by Ofer Shizav and Ryan Burnett. And they designed a rule set based on mod security, which would be generic in its blacklisting. This is an idea that says, do not all the SQL injections have some characteristic in common? Isn't there something which tells you this is a cross-site scripting without looking at the details, but it somehow looks like a cross-site scripting? Or it's a protocol violation, a general protocol violation. This must be an attack. That's the idea behind the core rules. And then they went about and wrote about 200, 250 rules which would restrict requests in this regard. So that's the core rule set. In the core rule set, you have rules against protocol violations, you have cross-site scripting rules, all sorts of injection rules. This is where mod security is very strong. A lot of SQL injection, OS command injection, PHP function names injections, whatever you want to think of. But then there are also rules which look at the application response, so the HTTP response. This is where you would see a Java stack trace or server error messages going back to the client, and you can interrupt those as well. Makes a lot of sense. And here you see in a very generic way. So if it looks like a Java stack trace, then you stop it, no matter if you've seen the stack trace before or not. And this core rule set has been around for like 8 or 10 years. It has died down a bit in development during recent years, and last year it started to pick up again towards the major release 3.0, the one which I'm going to talk about. You can use these rules in a legacy strict yes or no mode. So whenever one of these rules fires, then you block the request immediately. And of course, that has a lot of consequences to the left and to the right. Every false positive will stop the interaction. So what people usually do, and what I advise people to do, is run in the much better anomaly scoring mode. And I wanted to do a little demo with this, but then my computer didn't really want to work today, and I think, or I'm afraid, we have to do that with some people from the audience. First, we're going to need somebody with a hoodie. There are a lot of hackers around. Somebody must be wearing a hoodie. Come on, guys. We need a volunteer. You're the hoodie volunteer. Please come up on the stage. Okay, while we're waiting for him, we'll need 5 more guys afterwards. Hello. Hi, what's your name?
Andy.
That is Andy, very nice. Welcome to the stage. So we're going to do mod security core rules, and you have a hoodie. You're going to be the attacker. Would you put up your hoodie, please? as the attackers are doing. They're always doing this in the videos.
Which sunglasses?
As you wish. Okay, that looks really dangerous now. You can look out. Very good. Good attacker. For this demo, would you mind if we call you, oops, that's the wrong way around. If we call you Little Bobby Tables. You know the cartoon.
No.
You don't read the cartoon. For the rest of the audience, we need 5 more people. Would you send them up, please? So that's the famous XKCD guy where the mother is presenting or is filling an online form at the school with her son's name with the famous drop table students in it. And then the school calls and asks, is your son really called Robert, quote, bracket close, drop table student? She says, yes, we call him Little Bobby Tables. Okay, guys, please line up. We need you. Bobby, you stand over there. Nice. So you guys, you're going to be our core rules for this demo. I'm giving you score tabs. That's a +5 for you. You're going to be a +2 rule. You're not a very strong rule, but some indication is here. You're +5 as well. Here we have a +3 rule. No, you're not getting one. No, we have only 3 rules in this rule set. This would be 200 of these, guys. And we need you as the final gate. The point is, we're going to do anomaly scoring with Bobby Tables, and then we have 2 defenders at the end. Would you put up the helmet, please? It should be large enough for you. And you form a gate here, which he has to pass. Would you? No, you're a bit smaller. Come to the front. You go here. Okay. And I'm giving you the threshold stick. This is the threshold stick. Would you hold this very high and look a bit relaxed? You're a hippie rule set. You don't really care. You're a brand new install with very loose restrictions. And now what is happening with our request is that Bobby is approaching the chain. He's a request, and he has to pass all the rules now. And you go to the first rule, and now you decide, stop at the first, you decide, is he an attacker or not? And if you think he's an attacker, you put the +5 tag on his back. And then he goes on to the next rule. Oh, he's identified again. He's such an obvious attacker. Okay, he passes the first rule. The third, very good. And then he passes the final gate. No, he's not passing. And he has a score of 12 now, and he easily passes underneath. Very well. So you come back to the round. Please grab the tags again. And as the attacker approaches, as the setup is improving, they're lowering the threshold. And the lower they get, the harder it gets for Bobby to pass underneath. And after a few iterations, we're actually doing limbo dancing. Are you a good limbo dancer? No. You're not a good limbo dancer. But let's give it a try if you still pass underneath like this. Okay, usual stuff. Okay, this happens a lot. Every request runs through this chain and it passes. And the more mature that a setup is, the lower it gets. And it can get really, really low. Go down, guys. And look a bit fierce that you're, no, you're no longer doing it. You give up. Yes. You give up. You look for the next target. And that's the whole point. By a strict mod security installation, you shy the attacker away because it's getting too difficult for Bobby to pass underneath. Did you guys get the idea? Or should he do it again? Thank you. Okay, we no longer need you. Please give me back my helmet. So these core rules, they are very generic in nature. And with a generic rule set, of course, you also get a generic number of false positives. How many false positives do you get? You get a lot. You get that many. On the x-axis, you see the score of the individual request, and on the y-axis, you see how many requests scored the number. So you have some requests which scored 0 in this untuned setup. This is a traditional core rules 229, and some requests actually got 0 out of it. But the biggest amount of requests scored at 28. And as you have seen, the biggest tag we have is a +5, and with +5 to reach 28, you need at least 6 alerts. This means, in this setup, most of the requests scored 6 alarms in a single request. This is unnaturally high, but it's not that far off. So very often, this is what a new install is facing. It's a crazy amount of false positives, and in this setup, this represents millions of alarms. What you see on this graph is over 500,000 of requests and on an untuned setup. And all of these requests is scored 1, 2, 3, 4, 5 alerts, and far out to the right, there was an outlier at a score of 221. Can you believe that? That's really crazy. And that is a hard problem. And my job is actually to help people get rid of these long green bars and move them over to the 0 bar to have a lot of requests pass without any alarms. Of course, that's what you want to have. And this is called mod security tuning. And what I would usually tell people, don't be afraid. This is what we all face, but with a bit of guidance and a good policy, you can get rid of these false positives fairly quickly, and then you arrive at a functional setup. But of course, it would be better if the setup wouldn't have to be functional. If it would be functional from the outset, if there wouldn't be any false positives. And that's what the idea of the core rules paranoia mode is all about. And when the development of the 3.0 release was starting last year, I would enter the project again with the idea, let's do something about false positives. We could simply remove the rules, of course, but then we would lose security. That's not what we want. We want something which helps the user without compromising the security. And we have to improve the rules. And hence, the idea of the paranoia mode was born. So, how would you do this? The basic idea is we introduce paranoia levels. People tell me, look, Christian, the last thing that what mod security needs is to be more paranoid. It's already very crazy. And I say, no, hold on. The default will have a very low paranoia setting. In fact, much lower than it is right now. We introduce paranoia levels from 1 to 4, and then we take the rules and assign them to a paranoia level. And the default level is 1, and in the level 1, we only allow rules which we're quite sure that there are no or very few false positives. And then, as you rise through the levels, there are the more crazy rules, the more strict rules, the rules where you can expect false positives and where you have to expect false positives. And then there is a second concept in here as well. It is called the strict siblings. What we do with strict siblings, what we mean with it is you take an existing rule which has a certain limit, and then you duplicate the rule and add stricter limit. So it's a sibling of an existing rule which is stricter. And then on the next paranoia level, even more strict. And on level 4, it's very strict indeed. And this has been going on in winter and springtime, and we have now 150 rules left in Paranoia level 1. We have 30 rules in Paranoia level 2 and a couple of rules in 3 and 4, and this is where the development is still running. So the strict siblings, this is not yet done, but the mechanics is fully functional. It's there to be used. And when we set this up for the first time, you want to test it, of course. Testing an individual rule, that's fairly easy. But test the whole rule set, you want statistics, don't you? But then it's hard to do development on a productive release because you want the statistics, you want a lot of traffic. And traffic shouldn't be a single application, it should be representative. It should be typical internet traffic as a mod security installation typically faces. And it would be nice if there would be a project somewhere on the internet where people are providing you with a huge collection of internet traffic which you can then use to calibrate your rule set and setup. That would be very nice, but that's not existing. If you want such a body of internet traffic, you have to develop it yourself. And that's what I did. And what I came up with is I would run a man-in-the-middle attack on myself. So I would install a man-in-the-middle in my browser, and it would write down all my requests to the disk. And I would then translate this traffic into a usable form and then replay it against my own server. So the traffic which would be sent to GitHub or Slashdot or Reddit or anywhere would then instead be sent to my own server, to localhost, where I could play around with the rule set and run statistics and move rules to different levels, change the limits, introduce new rules, throw them out, and look how the statistic develops. And with this, we were able to design or put this call rules paranoia mode into practice. And with this, we ended up with first statistics. So what you see here is 5 different installations. In the top bar, you see the stable release, the call rules 229. And then the very small bar, that's the 3.0 development release with a default paranoia level of 1. And what we see is the average incoming anomaly scores. So of all the requests, this is the average score. And as you can quickly see, the average anomaly score is coming way down with the new paranoia mode. This immediately translates to false positives. That's a lot less alarms. And this is vanilla traffic. That's my own traffic. This is no attack traffic. Everything green here is definitely a false positive. And then as we raise the paranoia level to 2, 3, and 4, we get the alerts back. We get the false positives again. And in paranoia level 4, thanks to the strict siblings approach, we're getting even higher security and even stricter limits than we used to have with the call rules 229. So I'm going to show you now a couple of individual rules and showing you what we have done to them. The first one is a rule about restricted SQL characters. That's a very notorious rule among new mod security sysadmins, or sysadmin facing mod security first time. It's the rule ID 981173. It defines a long list, that's one of these crazy regular expressions, a long list of parameters, and then out to the right, you see a limit of 5. So this rule tells us, look, request, in any argument you're submitting, we're allowing a maximum of 4 special characters. With number 5, you're out. You get a tag on your back. You're tagged as an offender against 981173. And I'll tell you, this brings a lot of false positives. Depending on the application, you have cookie violating this. and the cookie is sent with every request. So every request triggers this alarm. That's really painful. And what we did in the new development release is this. The rule is removed from the default paranoia level, and then it's coming at level 2, but no longer with the limit of 5. Now we're allowing up to 11 special characters, and with character number 12, the rule fires. And then at paranoia level 3, we're bringing the same rule, or a copy of it. It's a strict sibling with a limit of 6. And then at paranoia level 4, we're bringing it with a limit of 2. And Bobby Tables told us he's not very good limbo dancer. And getting an exploit over to the server without using more than one special character is really hard. This is hard limbo. So if you're able to run your application at a paranoia level of 4, the attacker will have a very hard time. Next example, hex encodings. So hex encoding, as you all know, there's typically a 0 followed by X and then a hex number 0 to 9, A to F. There's a bit syntactic sugar around this in the rule, but basically it's 0x, etc. And of course, this brings a lot of false positives, namely in the form of cookies, session cookies. They're created by random, and as it happens, very often you have a 0 followed by 6 and then a new character. It's a false positive. It's a hex encoding false positive. And the plan now, this is not yet done, but the plan is, let's run this rule in paranoia level 1 on the parameters and XML stuff and the cookie names, but not on the cookie values themselves, as this is where the session cookies are. The session cookies on the request cookie values are only tested in paranoia level 2. So we're giving up a little bit of security, but reducing the false positives a lot. And if you have more need for security, you raise the paranoia level, and then you allow more false positives, which you have to tune. But then at least you know what you're doing. And request cookie contents is usually not the way where the attack happens. So I think that is worthwhile. We can do this for a default install. So these are 2 examples of rules on what we do in the paranoia mode. Next one, we have seen a bit of vanilla traffic, but what happens to the attackers? Do they notice this as well? Are they likely to get as few alerts as we've seen with the green traffic? No, that's not the case. Here we have Nikto scanning our server. Top row, again, core rule, stable release. And then on the paranoia level 1 of the new development, there are a bit fewer alerts. The average incoming anomaly score is a bit lower, but it's still at a 5 on average. That's substantial. And then as we raise the paranoia level, we're getting higher and higher. Actually, Nikto is nice that it does not trigger all that many alerts. If you look at SQL map, that's a lot higher. Here you see a substantial difference, but even on paranoia level 1, it's over an 8, which is already fairly high for an average score. This is probably why we're seeing much higher numbers than with Nikto here, is probably because the core rules are very strong against SQL injection, and of course SQL map is an SQL injection tool, so that's why you get higher scores. I also did a sample on the exploit DB. This is unfortunately a small sample. That's only a couple of hundred of exploits, and here the scores are even higher. You're up to 50 now in the default 3.0 development install. Good. Now, let's return to the rules and look at another advanced concept, a strict sibling concept. This was developed by Walter Hopp from the Netherlands. This has to do with PHP function names. PHP function names is also a source of a lot of false positives in 229 core rules installations. The problem is, of course, PHP is designed after the natural English language. And the natural English language has terms which also occur as PHP function names. There are innocent examples in the top left group. That's sleep, that's time. This is usually not used in an exploit. So even if we're seeing that, it's not really dangerous. Of similar low dangerousness is set locale or money underscore format. This is used in PHP. It's not used in English language, but even if it appears in a string, it's unlikely to be an attack. The two groups on the right, they are harder. These are the functions which are really used in attacks. In the lower right corner, you see group number 4, that's base64 decode or shell exec. That's really exploit stuff now. If you see this in incoming traffic, it's very likely something bad is going on. And this is a large group of requests, and what you want to do is run a fast algorithm against the list of these PHP function names, and you don't have to care so much about false positives because nobody writes proc underscore open in an email unless he is a PHP coder. But then the tricky bit is, of course, the top right. These are the dangerous function names which also appears in standard traffic. System, file, eval, or exec happens all the time. There's a lot of traffic. That's what people write in forums. And you cannot simply check for these keywords with a fast algorithm. You will get a huge amount of false positives. And that's happening in 229 to a wide extent. So what Walter Hopp did for the upcoming major release and for the Paranoia levels, he would group all the PHP function names that's far beyond 1,000 function names into these 4 groups and develop individual rules to cover them in the rule set. And for the group number 3, that's the system file except group, there we would make sure they're really occurring in a content that looks like PHP. If there is no bracket around, then it's unlikely that system refers to a PHP function name. And with this, he was able to reduce the false positively immensely while still catching a very big database of PHP exploits. So here we have a very good distinction between attack and benign traffic. Very nice rules. And I think this is developing into a generic pattern. If you have a long list of function names in any sort of language, dividing them into stuff which is appearing in the language, the natural language or not, and into dangerous and not dangerous stuff, gives you 4 groups, and you handle the 4 groups individually. And I think we're going to apply this to other languages as well. So return to the statistics. You have seen this before. This is my vanilla test traffic. This is myself, victim of a man-in-the-middle attack. And this is the combined attack traffic. You see the difference. This is huge. And Paranoia level 1, you can say, like most of these alerts, they are really the attackers. And then even on higher Paranoia level, there is a huge gap between green and red. So what happens if you put this next to one another? So now we have like the initial graph, we have the individual requests and how much they scored. Bobby Tables, how many numbers did he get on his back? What was his score? And now in Paranoia level 1, so that's the default 3.0 install, most requests score a 0 now. Green, but also red. And then there is no vanilla request scoring higher than 15, which is very nice, while as the attacker score way higher. Now, of course, you're asking, why are you seeing zeros with the attackers? The point here is, not everything what Nikto does is an attack. A lot of the Nikto requests are scans, is PHP MyAdmin installed? is this weak application installed? This is not an attack in itself, and mod security is not alarming when it sees this. It's just a path which will likely lead to a 404. So that's how we get zeros. But the real attacks of Nikto, SQL map, etc., they're happening further to the right, and we see a very clear distinction. And with a little bit of tuning, and mind you, this is a logarithmic scale. So 0 is way higher up on the roof, and 4, etc., is way lower. I made it logarithmic to show you that there is something actually happening with the green ones as well. People ask me, this paranoia mode, is it compatible with the anomaly scoring, the one which we did the demo? And of course it is. That's the whole point. People are supposed to ease into an installation now and have an easier way into this with a low paranoia level, a default setting at 1, at a very high relaxed threshold. So you remember the stick, and they were putting it up very, very high. That's relaxed. That's how you approach the problem. That's your first installation. You can go into production like that, and nothing bad happens. And then as you mature, you lower the limit lower and lower, and you end up with the security level of a standard site in the lower left corner. So low paranoia level and an anomaly limit, which is also low. Of course, I would advocate to use a high paranoia level, but being reasonable, we know that mod security is so hard to deploy nowadays that people refrain from using it altogether. And we would rather have a not so strong rule set, but have it really in a blocking mode. That's a lot better than not having the WAF at all. So I would say a low paranoia level combined with a strict low limit and very few false positives, that's a good default. That's what you should be aiming for. And then, if you have a higher need for security, and if your appetite for false positives is higher, then you slowly move up or raise the paranoia level to a higher level. And then you arrive at a high security site. What does not make any sense at all is to run the anomaly limit high with a high paranoia limit. This would be a combination of the bad things from the two worlds. So you would have no protection at all because it's a very hippie limit, and all the false positives which you can have. That's crazy. Don't do that. You either do a low paranoia level, or if you do a high paranoia level, you will want to run this with a low anomaly limit. Good. And 2 weeks ago, I was ready to fire this on a real production site. So that's the first production site, big production site, which would actually use the new development core rule set 3.0 with this paranoia level. And what I set up, I wanted to compare the behavior in an untuned setting with a lot of traffic. It's a high traffic site in Switzerland with the different rule sets. So I would set up 5 rule pipelines. I would set up a core rules 2 to 9, a stable release pipeline, then one for the new paranoia level 1, new rules paranoia level 2, 3, and 4. And I would get 5 pipelines and then run the request by random through one of these rule sets. And being a high traffic site, it's a content management system of a big corp in Switzerland with in the region of millions of requests per day, single-digit millions. We get a lot of traffic, and we're leveling out for the statistics, and this is how we ended up. It's a crazy amount of false positives for 229. So again, every single request scored, on average, at least 5 alerts. And this representing millions of requests, these are millions and millions of false alarms. But not the requests which went into the 3.0 development release with the default paranoia level. They didn't score exactly 0 on average, but almost. So really, way beyond 99% of the false positives are gone. And only when we raise the paranoia level to 2 or 3 are they coming back. And even if we have a bit of attack traffic in here, I know there is a bit of attack, but most of this is really legitimate and benign internet traffic. There shouldn't be all that many alarms, and I think this proves that the whole concept of the paranoia mode actually works in practice. Thank you very much for listening. The rest of my presentation, here are my contacts. It's going to be online, probably is already, photo sources. And if you're intrigued now to dive into mod security a bit more, I'm going to teach a mod security rule writing course and a core rule course in London in September. And it would be cool to see a few faces from you in London in my course. Thank you for watching. Thank you for listening. Are we taking questions, or anybody know if questions are allowed? I would welcome questions, actually. There's a question. Okay, the question is, why are we seeing such a big gap here between between paranoia level 1 and 2? This is fairly new, and there are not that many rules in paranoia level 2, and this is not the end of the story. We might get lower again, but then this is a very specific installation. This is actually, I can tell you, this is a Drupal site. And Drupal is really crazy with the parameter names. So what is happening here, that a lot of cookies are triggering a crazy amount of traffic. So being so far to the right, even in 229, is a bit extreme. So this is the first site where I used it. And when I saw it, these numbers are almost too good to be true. So the gap is not as high as that at a different installation. But it's likely it will be a significant gap because in paranoia level 1, we really want to have as little false positives as possible. And then, of course, there will be a high gap to the level 2 where you allow false positive at a reasonable number. It depends on the individual side, and there is still design going on. It's tuning, calibrating a bit. Okay. More questions? Okay. One question? No question? Okay, thank you. We're done.